Bonjour, donc excusez-moi pour les dernières semaines, j'étais un peu occupé et j'en ai décidé de faire un résumé jusqu'au dernier chapitre. Donc désolé pour la vidéo précédente. Il y avait in the previous video I just didn't found the word radius, like c'était simple, rayon. So the radius is rayon en français. Aujourd'hui on va continuer pour un résumé jusqu'au dernier chapitre. J'ai décidé de faire un résumé jusqu'au dernier chapitre du livre Airframe Stress Analysis and Sizing by Michael Neo. Alors, on va continuer en anglais. The book is one of the most widely used textbooks and professional preferences in the aerospace industry. It bridges the gap between theoretical mechanics and practical, hands-on sizing of metallic airframe structures. Next, in the next slides, there is a detailed breakdown and resume of the book's 17 chapters, organized by their core engineering focus. Important note: Michael Neo has another two primary textbooks in his series, which are Airframe Structural Design and Composite Airframe Structures. The part 2 is about the... We continue with the part 2. So as seen in the previous videos, the chapter 1 is like the general overview. It focuses on introducing the fundamental philosophy and of aircraft structural design. The key concepts is like explores the trade-offs in structural weight optimization of the weight, balancing aerodynamic requirements with structural integrity, and the critical concept of design of manufacturing to keep production costs manageable. Chapter 2 is sizing procedures. It focuses on the roadmap for inner frame stress engineer from initial concept to final documentation. The key concepts: preliminary vs production sizing phases, master sign conventions, tracking load paths, and drawing free body diagrams. Understanding drawing tolerances, stiffness, aeroelastic requirements, and the fundamental calculation of the margin of safety. So we continue with the part. So we continue with the part 1, which is foundations, sizing procedures, and external loads. So chapter 3 is about external loads. It focuses about determining the forces that act upon the aircraft. The key concepts: structural design criteria, aircraft weight and balance, CG limits, and the creation of the VN maneuver and gust envelopes. It outlines how flight conditions translate into design limit loads and ultimate design loads. The chapter 4 is material properties. It focuses about selecting the right metallic alloys for specific airframe zones. Key concepts: mechanical properties, aerospace, like aluminum 20, 24, 70, 75, 74, 75, titanium, and steel alloys. Focuses heavily on material allowables. We have documentations such like MPPDS, other documentations that defines the allowables of these heavily materials. So there's also the crack growth rates and airworthiness, regularity, compliance. So that's the chapter 4. The part 2 is about the structural analysis elements and beam theories. So the structural analysis focuses about a review of classic solid mechanics applied to aerospace structures. The key concepts is like Hooke's law, principal stresses, compatibility equations, solving determinate indeterminate structures using energy methods, and an introduction to the role of finite element modeling in modern stress verification. That's the chapter 5, the structural analysis. And for the chapter 6 is about beam stress. It focuses about evaluating bending, shear, and torsion on structural beam elements. The key concept is calculating the complex section properties, moments of inertia, symmetrical vs unsymmetrical bending, plastic bending behavior, determining the shear center, analyzing tapered beams, and calculating crashing loads on box beams. We continue with the part 2 which is structural analysis elements and beam theories. So the chapter 7 is about plates and shells. It focuses about analyzing the thin-skinned components common to wings and fuselages. Like the key concepts is bending and buckling of flat plates under pressure, stresses in cylindrical and hemispherical shells, the pressure cabins, and an introduction to sandwich honeycomb panel analysis facing skin stress and core shear. The chapter 8 is box beams. It focuses about the structural analysis of the definitive aircraft wing torque box. So the key concepts are calculation of the internal shear flows due to the torsion and bending, single cell vs multi-cell box beams, and the structural behavior of multi-flange and or multi-stringer cross sections. So this is the third part, which is about joints, fasteners, and stability, buckling and crippling. The chapter 9 is about joints and fasteners. So it focuses about analyzing the critical regions where loads are transferred between components. The key concepts is like riveted and bolted joint configurations. You can see the failure modes about fastener shear, sheet bearing, net section tension, tear out, and joint offenses. Detailed lag analysis like pins under shear and tension fittings, bolts under tension, including the effects of prying action, eccentric loading, and the use of shims. Then there's the chapter 10, column buckling. It's about column buckling, and it's about instability analysis of components under axial compression. The key concepts is Euler's long column equation, stepped and tapered columns, beam columns experiencing combined axial and lateral loads, and determining crippling stress for short sections where local elements fail before elastic column buckling occurs. So for the joints, fasteners, and stability, buckling and crippling, for the part 3, we continue with the chapter 11, which is about buckling of thin sheets. It focuses about stability of So for the joints, fasteners, and stability, backlinking and crippling, for the part 3, we continue with the chapter 11, which is about backling of thin sheets. It focuses about stability of thin skins under compressive or shear forces. The key concepts is general backling formulas for flat and curved plates under uniform compression, shear, or combined loading biaxial states. It highlights how thin aircraft skin wrinkling occurs before ultimate structural failure. Chapter 12 is about shear panels. So it focuses about deep beam webs operating in the post-backling regime. The key concept is analysis of shear resistant webs versus Wagner's pure diagonal tension fields. It details the interaction of flat and curved webs under diagonal tension, including the resulting induced forces of the surrounding stiffeners, vertical uprights, and caps flanges. So we move to part 4, which is about special design elements, life cycle, and testing. Chapter 13 is about cutouts, and it focuses about stress concentrations and structural modifications around openings like doors, windows, access hatches. The key concepts is like load redistribution around open or reinforced holes, analyzing unstiffened vs stiffened web shear beams, calculating double reinforcements, bent doublers around frames, and handling large cutouts in curved fuselage shell structures. Chapter 14 is about compression panels, and it's about comprehensive evaluation of skin stringer assemblies under compression. The key concepts is determining the effective width of sheet metal after skin backling, calculating inter-rivet backling limits, and analyzing various skin stringer configurations, X, Y, G, or hat stiffeners, alongside sturdy, integrally stiffened machined panels. Chapter 15 is about damage tolerant panels tension. So it focuses about structural longevity, the life of the fatigue, the life cycles, or the life cycles of the structure, the longevity of structure, the fatigue and fracture mechanics. The key concepts is cyclic loading spectra, fatigue life prediction, safe life, linear elastic fracture mechanics, LEFM, for crack growth tracking, inspection intervals, and residual strength evaluation for fail-safe multi-load path designs. So the chapter 16 is about structural salvage and repairs. It focuses about the real-world disposition of manufacturing discrepancies and in-service damage, like bird strikes, corrosion, ground handling dents. That's like the structural. There's structural repairs for such damages like dents, or there's key concepts is about engineering principles behind structural salvage, calculating repair patch thickness, design steps for flash or scab patch skin stringer repairs, and assessing structural retrofits without creating catastrophic local stiffness additions. Chapter 17 is about structural test setup. So it's about verifying analytical models through physical test validation. The key concepts is about setting up component and full-scale testing rigs, simulating complex load spectra, proper placement and orientation of strain gauges, and standard test methods for evaluating coupon or panel specimens like the éprouvettes, and pure tension, compression, shear, or fatigue. So as I said, I decided to make to do this resume through all the chapters about what it focuses about, the key concepts. Without you need really to read the book from the start to the end, and to understand, and you need experience in the stress engineering. So if you need to focus, you can focus also about repairs. For example, I didn't probably in these videos discuss it so much about kinds of damages that can occur in the production or in the maintenance. I didn't talk about so much about that, about the solutions that can be done, like oversize for some, or like oversizing for a diameter of fastener, or like oversizing a hole, a diameter for a hole, or for a joint. I didn't talk about, for example, like the shims, like the installing shims, or applying some load, or there are different kinds of repairs, like doublers, or there are many kinds of repairs. There are many kinds of damages, like a dent that can happen, and there are many calculations that can be done. Like there is also the corrosion calculation. I didn't go far away with in these videos, but as I said, I wanted to focus so much about the book, but in the end I just made this this resume from the start to the end, from chapter 1 to chapter 17. You can just have an idea, general ideas through these videos, 5 videos I think until now, but in order to have the stress engineering, you need to work. You need to really work on that to become a stress engineer. That needs time, needs experience, and you need to check. You need many, as I said before, you need many knowledges, and you need also to practice that in real life, with certification, in the certification phase, or for or concessions. So it's really interesting. There are many concepts. That's we talked about. I think only about metallic. There's also the composite. There's there are many tools that can be used for simulations. You need to have knowledge with Abacus, for example, for academic, but you need to know Hypermesh, Patron, Nastran. You need to know how to use. There are many other tools, but they are specific for the industry, like for Airbus industry or Boeing industry. But like there are other tools that are used to do simulations, whether for fatigue, whether for static, whether for damage tolerance. So that's it. I wish you all best, and thank you for your time.